honestly were two of the most common mistakes that we had on the quiz. And they're little things. These are two little things. They're very, very similar, but they're not identical. Okay. What do we get when we do -2 to the third? -8. Does this negative sign make it a fraction?
No.
No, because that's a negative in front, not a negative exponent. The negative exponent is what makes it a fraction. So this one on the right, this is 1 over 2 cubed, or 1 over 8. Okay? So it wasn't like not big sweeping changes. Y'all had lots of really good stuff and a lot of really good work on a lot of things. Not saying it was perfect. But these were the two most frequent mistakes I saw. This was a lot of people got these. Everything else was just kind of like little things everywhere else. Okay, so the quiz grades are in. They got in on Friday. We will have more quizzes. Do not fret about the 1 grade. It's okay. Remember, grades are still really, really volatile until we get to that first chapter test in September. Okay? So please don't freak out about those grades. All right, so that's not what we're talking about today. We are going to be talking about products and quotients of rational expressions. So fractiony things with x's, top and bottom, or top or bottom, things like that. In order to do that, we need to remember how to multiply and divide fractions. Just so you're aware, your first period teacher marked you absent. So send them a message. When we are multiplying fractions. Page. How do we multiply this? Across. 5 times 3 is 15. 7 times 4 is 28. See if it can be simplified. It can't. Your answer here is 15/28. Okay, looking at the division, what do we do when we're dividing fractions? Butterfly can work. Or we can do keep, change, flip. Remember that? Like KFC, but KCF. So we have 5/7 times 7/2. So when you have division, if you are very careful and remember which one goes on top, I can see the argument for butterfly, but just make sure you're very, very organized with it. I'm going to do keep, change, flip. Okay. Then we get to multiply these across. Or we can simplify right here. What can I simplify right here? The 7s are going to cancel out. So this one is going to be 5/2. That's a 2, not a Z. Okay. It's going to get more than that because we have, letters. But questions on those two? Vaguely familiar? Because they going to get weird. I'm going to make it so you can actually zoom in and see. All right. So the first one, we have 9y squared over 8 times 32x over 27y. Nine y squared over 8 times 32x over 27y. And we're multiplying. So we're going to multiply across. We can also simplify a little from here. What can I simplify? The 9. What does the 9 cancel out with? Part of the 27, leaving us with how many left? 3. Anything else we can simplify? the y. So I've got this y is going to cancel out one of the y's up here. Anything else I can cancel out? The 8. With how many are we going to have left on the top? 4. So it's getting a little crossy-outy for me, so let's simplify this. We're left with 4xy over 3. If your paper starts to get too crossy-outy, simplify it so you can look again. Do I have anything else I can simplify? No. Nope. This is our simplified answer here. That's my answer. Okay. Vaguely familiar? Because again, this is another one of those things we spent a whole chapter on in Algebra 2. Whole chapter on these guys. Because remember, they gonna get worse. They gonna get worse before they get better. There we go. We've got x squared minus 16 over x squared times x squared minus 4x over x squared minus x minus 12. There we go. Oop. Not any cooler in the hallway. All right. When we're doing this and we're looking to cancel out, we cannot cancel out things that are being added or subtracted. But if I put it into factored form, where things are multiplied together, then we can cancel things out. So, my x squared, I can't do anything with, that's in a denominator. That's a squared. How about this numerator, this x squared minus 16? What can we do with that? It's a difference of perfect squares. X plus 4, x minus 4. I heard both ways. Perfection. Now we are times this numerator, x squared minus 4x. What the heck is going on with my pen? There we go. What can I do here? Pull out an x. It's got a GCF of x, leaving us with x minus 4. Then our denominator. This is a trinomial, so let's go ahead and do our frame. Minus 12 and minus 1. Pair of numbers. It multiplies to be negative 12, adds to be negative 1. 4 and 3, which one's negative? The 4. So this is x minus 4. X plus 3. I don't care how you factor, just that you factor. Factor whatever works for your brain. Any questions on how we went from here to here? Cool. Now we gotta simplify some stuff. What do we have that cancels out? I've got an x minus 4 that cancels out there. Anything else? An x cancels out with one of those. And I don't see anything else that we can cancel out there. So our simplified answer, and we're just going to leave it in factored form. You don't got to remultiply it out. X plus 4, x minus 4, and on the bottom we have x and x plus 3. And this is our simplified answer. Zooming out so we can see the whole page. It is hot enough in here, my water bottle has steamed up. It is so hot in here. My water bottle has a steamy top. I'm dying. Okay, questions on these two? Feeling okay? because you know we get more. We're going to do some dividing. I'll zoom it in so we can see them because I know that's a lot. It gets a little overwhelming. So here's our first one. Now we have A's instead of X's, but it means the same dang thing. A squared minus 6A plus 9 over A minus 3 divided by A minus 3 squared over A squared plus 3A minus 18. Okay. Game plan is the same. Factor as much as we can. So let's take our numerator and start there. How can I write this in factored form?
A plus 3A minus 3.
No, it's not a difference of squares. It's A minus 3, A minus 3. It's A minus 3 squared. When in doubt, make yourself your little X frame where we have our positive 9 minus 6. That'll help you see that. Our denominator is still that A minus 3. I'm going to switch this to be our multiplication here, which means I got to flip my next fraction upside down. My pen is being super grumpy today. It's just so sweaty in here. It's sensing my glove as a finger. So what was our numerator now becomes our denominator. A minus 3 squared. I'm going to write it out this way. And what... Like if I wind up hearing new music, I will dance and it will be bad on purpose. Okay, so what was the denominator is going to become the numerator. So we have our minus 18 and 3. Pair of numbers multiplies to be negative 18, adds to be 3. 6 and negative 3. So we have A minus 3, A plus 6. And we get to simplify now. And we have a whole lot of pieces that are the same, so we need to make sure we're being real careful. Because I can take this A minus 3 out with that A minus 3. I can take this A minus 3 out with that A minus 3. I need another color. Let's do the bright green. And I can take this A minus 3 out with that A minus 3. So lots of them cancel out. And we are get left with just A plus 6. Over 1 if you're feeling real froggy and you need to keep your fraction. But that's our answer. So that whole hot mess, this whole thing simplifies down to just A plus 6. Extra. Okay. One more of our dividings, and then we're going to move on to the next piece. Because you know we get more pieces. Yay! So we got 4x squared minus 9y squared over 8x cubed minus 27y cubed divided by the quantity 2x plus 3y squared over 4x squared plus 6xy plus 9y squared. That one is a beast. Lots of pieces here. Lots and lots of pieces. So we're just going to take it chunk at a time. So let's start with our numerator over here. What can I do with this guy? It's a difference of squares. So we're going to have our parentheses. 4x squared is going to become 2x and 2x. 9y squared becomes 3y. 1 gets a plus, 1 gets a minus. You okay? Okay. This bottom one, we talked about this on Friday. That's the funky cube thing. Our difference of cubes. Where I'm going to find, and I'll put it down here, my cube root of 8x cubed and my cube root of 27y cubed. What's the cube root of 8x cubed? 2x. What is the cube root of 27y cubed? 3y. So we have to set up that pattern. And we have our 2x and our 3y. This is when we think of SOAP, so the same sign, so it's going to have a minus. We take that first piece squared, so we're going to have 4x squared with the opposite sign, so it's going to get a plus. This piece times that piece, 6xy. This piece squared, 9y squared. So this pattern we should have in our notes from, I was going to say Thursday. Let me see. Oh, it may have been before that. Yeah, I think it was Thursday. Oh, no, it was Friday. It was from Friday that we did that. Okay. So, that's the first piece. And I'm going to fix that square because that's going to drive me nuts. There we go. Then we have to do our change the sign, and I'm going to flip my second fraction. Our numerator is going to become in the denominator. That one is very easy. This piece here, can we factor him? Nope. We just go write him up on top and call it good. I'm going to put it in parentheses so we can think about it. But other than that, he's just going to hang out. So this is our factored form. And we're ready to play crossout games. What do we see that's the same top and bottom? That gross guy. This piece is the exact same as that piece. They get to go away. Yay! Anything else? The 2x plus 3y and a 2x plus 3y. And then we also have a 2x minus 3y and a 2x minus 3y. So we're left with the 2x plus 3y in the denominator. Make sure you don't give it to me as a numerator. It's in the denominator. It's got to stay in the denominator. It is hot here. It is like, it's been hot all morning. I knew this class was going to become.
Right next door is always
Her room is cold. Next door to me, literally sharing a wall with me. I don't know. It is hot in here, and it has been hot all morning. I'm like, of course, the day I choose to wear like long sleeves, I'm dying. I'm dying, and I'm gonna die all day. I don't know why, but it is hot in here today. It is never hot in here, but it's hot in here today. I knew it was gonna be awful in this class because we have so many people. Okay, how are we feeling on our multiplying and dividing hot mess of crazy? So great. I'm glad it's so great. I'm just going to do this so that we can tell where those two pieces are separated. Because we're not done. Of course we're not done. Because we're going to add and subtract fractions. So sums and differences of rational expressions. What do fractions need to be able to add or subtract them? Common denominator. I'm just going to put denom, which I'm not going to spell demon, but denom. So looking at 3/4 plus 2/6, what do they need to have as their common denominator? What is their lowest common denominator between 4 and 6? 12. So this one is going to be 9/12, and this one is going to be 4/12, which gives us 13/12. Same thing is true when we subtract. What is the common denominator? 15. And there's two different ways of thought to think about how you get from here to that. You can either multiply both pieces by 15, or you can multiply this one by 5 and that one by 3, either way. So either way, we should wind up with 10/15 minus 3/15, giving us 7/15, right? Okay, because we're about to kick it up a notch and throw some letters in. We do. I know we don't want to, but we do have to do it. Okay. Zoom in, so we only see one at a time. So we've got 5/4x squared y plus 3/14 xy cubed. And we need to get to a common denominator. So our least common denominator, what pieces does the denominator need to have? How many x's do we need to have total? X squared, right? How many y's does it need to have? 3. So y cubed. How about the number? What is our lowest common denominator between 4 and 14? That's lowest common factor. 28. So our common denominator is going to be 28 x squared y cubed. So what you can do on these kinds of guys, we can multiply this one by 28 x squared y cubed. 28 x squared y cubed. So we're going to wind up here with because the 4 is going to cancel out, leaving us with 7 x squared and the y. So we're going to wind up with 35 y squared over 28 x squared y cubed plus, my glove is being a jerk, 6x over 28x squared y cubed. Does that make sense to you guys, or do I totally lose y'all? Like, I don't like having that written there. That felt weird. Did everyone see how we made those two jumps? We've got to get to that common denominator. We found our common denominator. We've got to get there. Look for what pieces you're missing from your denominator to get up to that common denominator. Once we're there, we just got to add those two together. Can I add these two together? No, so we're just going to stack them next to each other. 35y squared plus 6x over our common denominator of 28x squared y cubed. That is how we add them together. Get to that common denominator first. You got to have a common denominator first. So when we have polynomials like the next one, we're going to have to multiply at least one piece. Get it into factored form first. So I'm going to factor, at the very least, the bottom. We can't do anything without knowing what pieces make up this guy here. So we're going to have minus 24. Why is my pen being a jerk again? Over minus 2. What's our pair of numbers that multiplies to be negative 24, adds to be negative 2? Negative 6, positive 4. So we can write this one in factored form as x minus 6, x plus 4, right? I don't feel like rewriting. Yes, ma'am. You don't need to distribute it beforehand. Let's get them to have the common denominator, and then we'll subtract our top lines. So if our denominator has these two pieces, what piece is that guy missing? The x plus 4. So we're going to multiply it by 1, but a weird looking at 1. X plus 4 over x plus 4. That's going to give me a common denominator so that I can subtract. This numerator, we're going to want to subtract from that guy. So I want them to look the same. So I want to multiply that guy out. So we're going to have x squared plus 4x. Hi, Henry. I'm just on my desk. It's fine. Plus 2x plus 8. Our denominator is x plus 4, x minus 6. And we're taking away this x squared plus 5x plus 24. Okay, where'd I get what? I heard that. Okay. This piece turned into those. I multiplied by a funny looking 1. And then I multiplied this guy out to get this. Okay, we see where all the pieces come from? Okay. So now we have a common denominator, and I can subtract my numerators. So we're going to do, as like if it helps you to write the whole thing out, you can. X squared minus x squared plus 4x plus 2x. I'm going to make that plus 6x minus 5x plus 8 minus 24. You do not have to write this step. I'm just making it so that we can see what the heck is happening here.
Why is it minus 5x?
Because we are subtracting this whole piece. Okay, so that's why I put those ones in purple. The purple come from here. We are subtracting all of these pieces. Yes. The 24, 14, sorry. Oh, I've written that twice wrong. Sorry, that's the 14 from the numerator. That's this 14, that comes down and to be that 14. Thank you. Call me out if I write something real crazy. Okay. Feeling like we can finally see the logic in there because it didn't go crazy in that halfway through that time? Okay, so now we're just simplifying our numerator, and we're almost done. Oh my gosh, these are so long. Holy cow. So our x squareds cancel out. We love that. 6x minus 5x gives us 1x. 8 minus 14 minus 6 over x plus 4. X minus 6. Are we done? Is it fully simplified? Why not? Because x minus 6 over x minus 6. And holy cow, one more step. Oh my gosh, those cancel out. And we are left with 1 over x plus 4. And this whole hot mess of a problem simplifies down to 1 over x plus 4. Why can't they just start there? Right? It's a lot. These are a lot. Okay? So, I'm actually going to jump a page. Actually, no, we're not. We're going to look at this one. All right. We're going to do a couple more. We're going to do as many as we can. All right. X minus 4 over x squared plus 5x plus 6 plus x plus 1 over x squared minus 4. So first things first is I need to factor everybody so we can figure out what the heck we need to do with our denominator. So my numerator, I'm just going to leave the same on both. X minus 4 and x minus 1. What's up?
I can't remember. Is that you that said that, like, if you were hungry, that you had snacks? See, it was her. Like, I'm crazy.
Can't learn hungry. But I'm trucking. Like, I'm flying, so grab them at your leisure. Y'all, I only got so many granola bars, yo. Say thanks to my mom. All right, we're continuing to factor. multiplies to be 6, adds to 5. So we have 2 and 3. So we have x plus 2, x plus 3. Y'all pick one. Our denominator on this side. It's the difference of squares. X plus 2, x minus 2. This is an emergency snack situation, not a everyday you come get a granola bar from me. I don't have that many. I have 150 kids, and we have 180 days in the year. That's a lot of granola bars. I'm a public school teacher, y'all. I ain't got that kind of granola bar money. Okay, so we've got it into factored form. Let's figure out what our common denominator is. What pieces need to be in the denominator? We need an x plus 3 in the denominator. We need, what else? X minus 2 in the denominator. What else do we need? And an x plus 2. So it's going to have three pieces in there. And I said the word 3 while trying to write a 2, and therefore it went weird. Okay. So that is our common denominator, which means I'm going to need to multiply both fractions, which is okay. So my left guy over here, the piece that he's missing is that x minus 2. My right guy, the piece he's missing, is the x plus 3. Right? You see how that's going? Since we're trying to add these numerators, and I cannot add them when we have pieces being multiplied, we need to figure out how to make them look like they're being added. Multiply them out. Leave the denominator in factored form. So when I multiply out the left side, we get x squared minus 2x minus 4x, which is minus 6x plus 8. And we're adding our other fraction. It's okay to take a shortcut here. X times x gives us x squared. Minus 1x plus 3x gives us plus 2x minus 3. We know we're adding them all together, so I'm just going to do it in one big fraction so I don't have to rewrite it again. With our common denominator of x minus 2, x plus 2, x plus 3. I combined like 2 to 3 steps in this one jump. So that's a lot of pieces that I smushed together here. You okay? Anyone lost on any one of these 3 steps? Because we multiplied these two, we multiplied these two, and we put them on the same line to add them together for our common denominator. Okay. So let's simplify the dang thing. Woo! We're almost there. Because we have x squared plus x squared giving us 2x squared minus 6x plus 2x giving us minus 4x plus 8 minus 3 plus 5 over our big old denominator, x minus 2, x plus 2, x plus 3. And before we can say we are done, we have to look and see if that dang thing can be factored again, just in case they're giving us so much extra work. So when in doubt, check and see if we can factor it. 2 times 5 gives us 10, negative 4. Is there a pair of numbers that multiplies to be 10 and adds to be negative 4? No. So it's not factorable. So this is our answer. Okay? Find your common denominator. multiplied by funky looking ones. We're just truck past it and go from there. On the homework, there's ones that look like this. Remember, giant fraction just means it's division. This is this guy times 1 over h, or divided by h. It's the same dang thing, common denominators. All right? We'll probably do one of these tomorrow before we move on to the rest of it. Homework 1-4. We've started it. Due Wednesday. We've only done the first half of it. All right? Y'all have a minute and a half until the bell. Please turn in homework 1-3.